In this lecture, I'll show you how to search for a string pattern in a text file. This is especially useful because the Linux configuration and log files are of type text and is common to search for a specific option, message or error. We'll talk about the grep command. Grep is one of the most useful Linux commands, even though it was created by Ken Thompson, one of the pioneers of computer science, as a private utility more than 45 years ago. The grep command searches in a text file or output of another command for a pattern referenced to as a regular expression and prints out all lines that contain the pattern. To search for a pattern in a file, you write grep, optionally some desired options, the pattern to search for, and the name of the file as a correct absolute or relative path. I'm searching in the configuration file of the SSH client for the string user. Grep, the string, the pattern, and the file, etc ssh_config. And it displayed all the lines that contain the string user. There are two lines. If the pattern contains spaces, you should enclose it in quotes, like grep, and between double quotes, let's say command line, and the file, the same file. And it found the lines that contain the pattern. To ignore the letter case, use the -i option. Grep, SSH, written in capitals, and the file. And it didn't find a thing. Now I'm gonna search it by ignoring the case. So I'm adding the -i option. -i comes from insensitive. And it found a lot of lines. To print the line numbers on which the pattern was found, add the -n option. So -n. And it printed out the line number as well. Of course, you can group multiple options like this. It's the same. To search for whole words, use the W option. Let's say grep, body, etc, password. And you see that grep searches for any sequence of characters, not only whole words. And it found the line that contains the string nobody. Now I'm adding the -w option. And it searched for whole words and didn't find a thing. To invert the sense of matching, so to select non-matching lines, use the -v option. V comes from inverse. So grep kernel /var log dmessage. It found a lot of lines that contain the string kernel. And now I'll invert the match. And it found all the lines that do not contain the string kernel. If you want to search for a string in a binary file as if it were a text file, use the -a option. Grep root /var log auth.log. And it says binary file, the name of the file, matches. This is in fact a data file, a special kind of text file. To search for a string in such a file, I have to add the -a option. And it found all the lines that contain the string root. If you want to search for a string in a directory, it will return an error. I'm searching for the loopback interface IP address in /etc. So grep, the IP address of the loopback interface 127.0.0.1 and /etc, the directory. And it says /etc is a directory. What I can do is tell grep to go recursively in /etc and search for the pattern in every text file in that directory and all its subdirectories. I'll use the minus capital R option. And it displayed all files that contain that string, which is the loopback interface IP address. Of course, grep doesn't have the permissions to read all the files, but I can run the command as root. By the way, if you want to suppress error messages about non-existing or unreadable files, add the -s option, like this. If you just want to see the number of the matches, use the -c option. I'm searching for the string error in a log file. So grep -c error, the pattern I'm searching for, and the file. varlog syslog. And it found 9 matches. So there are 9 lines that contain the string error. Of course, I could get the same result by using a pipe and the wc-l command. So grep error, the file, these are the lines, and I'll pipe the output to wc-l. Now there are 10 lines. A new line was written to that file. The grep command can be used to search in the output of another command as well. In the next example, I'll display the kernel ring buffer using the dmessage command and then search for possible error messages. Dmessage. This is the kernel ring buffer. It's printing out the kernel ring buffer. These are kernel logs in the RAM, most of them produced by the device drivers. So I'm filtering the lines that contain the string error. Dmessage, pipe, grep, and error. And there's a single line. If you want to see a context, and that means a few lines before and after the match, I can run grep -a, let's say 3, and -b 4. It printed out 4 lines before the match and 3 lines after it. This is what the -a and -b options do. You can also use -c from context and the number, and it will print out the same number of lines before and after the match. I want to see 3 lines before and after the match. So -c 3. 3 lines before and 3 lines after. Another common example is to check what program is listening on a specific port. To display all ports, run netstat with some options. Run it as root. So sudo netstat -tupan, and it has displayed all open ports. And to check if there's something that's listening on port 53, filter the output using grep, like this. Pipe grep 53. And there are some processes that listen on that port. Let's check if port 80 is open. And there's no process listening on port 80. Let's see the last example. ls-r and f /etc. I'm listing the etc directory recursively using the -F option, which adds a character at the end of the file depending on its type. This is the output. This is an executable file. This is a symlink. And these are directories. The output will be piped to grep, which will exclude lines that contain a /. These are the directories. So pipe grep // and -v to inverse the match. I want to exclude directories. There's no directory in the output. Then I'll exclude the empty lines. To do that, I'll use something special called the regular expression. So pipe grep -v, I'm excluding the empty lines. And now the regex for an empty line. Caret and $. Caret means the beginning of the line and $, means the end of the line. So in fact, I'm excluding the lines that have a character between the beginning and the end. No empty lines. Let's see how many they are. I'll pipe the output to WC-L. And there's this number. I can ignore those permission denied errors, or I can run the command as root. And finally, to sort the files by name, I run the sort command on the output. Pipe sort -r. -r will do a reverse sorting without WC-L, like this. And the output was sorted by name in reverse alphabetical order. To see it better, I can pipe everything to less. Without the -r option, it will sort the output in ascending alphabetical order. All files that start in A, then the files that start in B, C, and so on. And I can redirect the entire output to a file as well. See how I'm using multiple different commands and pipes to get the data I want. That's all. Take your time to deeply understand how grep works. It's one of the most useful Linux commands.